About the monitoring environment. They build it, they create it, and in 3 seconds we are able to start.
Thank you. Can everyone hear me, by the way? Is this thing loud enough? It's not loud enough? Can you turn it up a little, or is that possible? Hello, hello, hello. Test, test. Okay, otherwise I'll just, there we go. Okay, well, good afternoon, everyone. I'm Jeffrey Lensen. I'm a system engineer at a Dutch company called Hyves.nl. To give you a little idea about what Hyves is exactly, because I'm assuming most of you have never really heard of Hyves. We're a Dutch social networking website. Currently the biggest one in the Netherlands still. We have about 10 million Dutch users, and they generate about 3 billion page views a month. Well, I'm not going to read all the statistics here. So just to give you an idea, we have about 100,000 photo uploads a day, and they generate about 6 gigabit of daily outgoing traffic. To give you a little more information about what our technical environment looks like, we have about 3,000 hosts, which are all running Gentoo, so it's just one big cluster. They're divided over 3 data centers, so we have 3 different locations. These 3,000 servers, we can divide them into around 190 different types of servers. So we're talking web servers, database X servers, database Y servers, caching servers, you name it. We have 160 employees at our company. Our system engineering team is a mere 12. We have 45 developers, so we're pretty much outnumbered at our company. Before I start talking about our current environment, I'd like to take you back a couple of years. About 5 or 6 years ago when I joined Hyves, we had a mere 150 servers. They were all in one data center. We had just 4 system engineers back then, which was me, another intern. We had one full-time system engineer and another one also working on his thesis. Like most of you, we had just the one Nagios instance, which was monitoring the whole thing, and it was complete manual configuration. Now, at some point, Hyves became rather popular. We had people telling other people, hey, look at Hyves, it's great, and you should join. And more people started joining, so that required us to expand our server park for storage or performance reasons. And we started receiving batches of 100 to 200 servers at a time. And that makes manual configuration of your Nagios setup quite unmanageable. I mean, if you're unboxing 200 servers with just 4 persons and racking them in a server park, then you don't want to go back to the office and manually type in 200 servers and check this, check that. So we had to do something about that because this was not going to last long. So what we did was we started creating templates for hosts and host groups. We defined our service checks per host group. Because all of the machines within a certain host group pretty much had to have the exact same things checked. And we created scripts to fill up these templates based on the information that was in our server management database. We have this database which is home built. It contains information of all of our servers. It tells you what the IP address is of the machine, what the function is of the machine, where it's racked, everything. So we have a pretty up-to-date source of what's going on in our server park. The service dependencies were generated as well, because you don't want to type in saying, if NRPE doesn't work, then this doesn't work, this one doesn't. So what I started doing was prefixing all of our check names with check NRPE, check SNMP, check whichever, and based on that, I built the entire service dependency configuration per host. But unfortunately, well, not unfortunately, because I mean, it's great, we kept on growing and growing even more. So at some point we extended to 3 data centers. Our server park grew even larger to about 1,500 hosts at the time, and it was starting to get a problem, started to become a problem, sorry, to monitor the whole thing with just a single Nagios instance. Especially if you have 3 data centers and you lose one uplink and you get your mailbox pretty much full with all of the machines in that data center that they're all down. So we started setting up a distributed Nagios setup. I don't know how many of you have actually set up a distributed Nagios setup, but this is, as far as I know, pretty much the default way to do it. You've got one central Nagios server, which has the entire configuration for all of the distributed hosts. We use it for monitoring and for the web interface, because you want to be able to see in the web interface what the status of your entire server park is. Around that, we had the 9 distributed monitoring hosts. It required a little bit of changes to the current scripting we had to generate the configuration, because we had to spread it out over the 9 distributed Nagios hosts. So what we did was, based on the name and the location of that monitoring server, we created a list. Sorry, let me start over. We created configuration files, which contained a list of function types that we had. And we did that for 3 parts. And based on the name of the Nagios server, so you had Nagios 1-DC1, Nagios 2-DC1, et cetera, it would take that configuration file and build a automatic configuration based on what was listed in the function config. Now, one of the problems we had, and some of you may have had as well, what happens if you lose your Nagios machine? When you can put freshness checks on all of your checks and wait for them to eventually start complaining about, I haven't received any updates about this service for the last, I don't know, hour, 30 minutes, whatever you want. But that means, again, getting a long list of all of the machines that haven't been checked in a while. So what we started doing was we set up a NOC monitoring machine, and we had that machine monitor all of the network peripherals and the Nagios machines themselves as well, just to make sure that they're still functioning the way they're supposed to function. That worked pretty well for quite some time, but at some point our central server, he started having some very big problems with the large configuration. That was mostly during reload, so if you reload the Nagios daemon, it would just take a very long time for that thing to actually boot up. That basically means that in between when it went down and when it's finally done loading, you don't have any monitoring, any alerting, you have nothing. And the biggest problem that we had was that the monitoring server would just freeze when we had some large fallouts. We lose a data center, then it sends out a bunch of text messages, and it would just freeze. It tried to send out the notifications, but it couldn't get them out, and when it can't send out the notifications, it's not processing any of the other incoming checks that were coming in. And the web interface wouldn't load anymore. So if you try to pull up an overview of all of your problems, then the web interface, it just wouldn't start anymore. So what we did back in November 2010 was we started looking into Icinga. One of the things that drew me to Icinga was the fact that it doesn't require a central monitoring host, so you can basically just keep on scaling your monitoring hosts if at some point you need more. The standalone web interface, you don't need to have the web interface necessarily on the exact same machine that's doing the monitoring. Same thing goes for the database backend. You can just set up 2 new machines with the database and use that. Then there's the API, which I started thinking about and had some pretty good ideas about how to get that working and what to do with it, the possibilities that came with that. The rapid development for Icinga, and there were a lot of people working on it. And best of all, migration was relatively painless. The only thing I needed to do was run one set command to replace everything that's called Nagios and replace it with Icinga, move the configuration files, start the whole thing up, and it was done. And this also meant that we could still use the scripting that we already had to build the configuration for our new Icinga machines. To give you a little information about the Icinga setup that we currently have running, we've got 12 Icinga hosts running right now. We still have the one NOC host. Right now they're checking about 100,000 service checks, and we grew to about 3,500 machines in our 3 data centers. I put a little graph in here. I don't know if you can actually see it, but during peaks we do about 15,000 checks per minute right now. And as you can see, they're all scheduled active checks. So we don't really use any passive checks. It's mostly just active checking. We also split off the web interface and the database hosts. What we did was we set up 2 machines with a MySQL database backend, put them into circular replication. So it doesn't matter in which one of the 2 machines you insert your check results. It'll always end up on both machines. That also means that you can load balance them, so you can just, load balance them. And you can also load balance the API, so if one machine can't handle any of the API requests that need to be done, you can just put 2 machines in that load balancer, have that web interface running on those 2 machines, and you can just use the API. And this also allows for some very handy failovers. So if one of those 2 machines dies, you just kick it out of the load balancer and keep running, and there's no one that actually knows the difference, except for me, because I have to fix it. But oh, and one of the other things is we don't actually load balance the web front end, because you have the logged in sessions that were causing some problems when we started load balancing that. So you also need to change one DNS record to move the CNAME to the other host if that's necessary. Okay, so actually making use of the API. One of the things we started doing early on was grouping certain checks for certain host groups together in order to minimize the amount of notifications that you get in. I mean, if someone at development screws up somewhere and has all of the web servers crashing, I don't want to get 250 notifications saying, oh, your web servers aren't running anymore. I just want to get the one notification that says, oh, hey, I've got 250 web servers that aren't running. I mean, we've had that at the beginning, that we had large amounts of text messages arriving. And I think I actually managed to kill a couple people, their phones. Yeah, a couple of colleagues that their phones actually crashed. So that makes it even harder to do your standby shift if you crash your on-call telephone. A small example here is it's a Python script. It uses some of the libraries that I've created, but I'll get into that later. It's called Check Monitoring Overview. You specify the host group, you specify one or multiple services that need to be okay, and you can specify warning thresholds based on a percentage or just a regular number. In this case, all of the web servers were fine, and it's all good, so I didn't have to do anything. Okay, missing monitoring. Some of you may have had this problem as well. You've set up a great monitoring environment, you think everything's running perfectly fine. Then at some point, someone walks up to you and he's like, hey, did you know that database this or that died 2 or 3 days ago? And I'm like, 2 or 3 days ago? No, I don't think so. Why should I? Yeah, it's on this and that machine. I'm like, I don't know if there's a database running on that machine. Yeah, I set that up last week. And I was like, okay, and you're assuming that I know that you set that up and that I automatically arrange monitoring for you? I mean, I have better things to do than go through the entire server park to see if anyone changed or added anything. So you tend to get a lot of angry people at that point. So our solution to this problem, Puppet. We've been using Puppet for a couple of years now. Puppet's a configuration management tool. It allows you to create a list of modules for well, Nginx, Postfix, SNMP, and you can create a role module in which you basically define that this server needs to have this installed, that installed, that installed, and that installed. So Puppet pretty much knows everything. I mean, we install our servers quite rapidly, and we have Puppet configuring them. So within 15 minutes, we have a complete server up and running, freshly reinstalled. So everything that needs to be on a server is in Puppet. So we figured, why not use Puppet, right? To give you a small example of how the Nginx module in this case would look in Puppet, I mean, this is just a very basic example. You specify the package, you say this machine needs to have Nginx installed and the service Nginx needs to be running. And then in the role, you specify that the web server role, which is the name of the function as we have defined it in the server management database, and needs to have Nginx included. So, luckily for me, Puppet already supports Nagios resources. So I didn't really have to change much there. All I needed to do was define them and use them. These resources, they're typically called exported resources. Why? Because a regular resource would generate a file on the local machine, and generating your monitoring configuration on the machine itself doesn't really make much sense if you need to have it monitored by your monitoring servers. So what happens is these exported resources, they're generated and they're stored in a MySQL database backend or Postgres or whichever you want to use. And we started to define our monitoring checks in the matching module. So if you take the example of the Nginx module, you add that piece of code there and that's it. So we've got the HTTP servers. You specify which check command needs to be used as it is defined in your check command configuration. You can specify event handlers. You can specify contact groups. You can specify everything. Now, because I'm a relatively lazy system engineer and I don't want to keep on redefining every single thing every single time I add a new monitoring check, we predefine that stuff. So what we do is we predefine for the Nagios service exported resource that it needs to be present, because if it's not present, then it's still not going to be there, so it doesn't make much sense to use it. And we predefine the host name with the host name and the domain variable that Puppet has. We say use the generic service template as we have defined it, and make sure that the notifications are either enabled or disabled. So what this thing here is, it's a local variable, and based on what the system status is for the global variable, it returns either operational or fail, and it turns the notifications on if it's operational, and if it's failed, it'll turn it off, because personally I'm not very interested in HTTP not running on a web server that's not even operational. I mean, sure, I'm interested, but I don't want to get a text message or get it in my mailbox. You can specify the target, so you can say, I want to have this service check defined in this file. Now what we did was we defined it in a host-specific configuration file, and we used the notes. We used the notes thing to specify the monitoring host. Now this monitoring host is a global variable again. Very early on in the Puppet run, it creates or it connects to the database, and it gets all of the operational monitoring hosts that we currently have and that are in the exact same data center, and it picks one of them based on the modulo and puts that in the variable. Now, if for whatever reason we don't have any monitoring hosts in that data center, we also have a fallback to choose one of the other monitoring hosts that we have, just to make sure that it's always present. We do the same thing with specifying the Nagios host, specify the host name, specify the host groups to make sure it ends up in one of those host groups. Template again, alias, notifications again, on or off depending on what the status of that server is. And in order to specify the exported resource for the Nagios host, we have a class called monitoring, and the only thing you need to define is the address because the rest is already predefined. We then include that class within the role module, which is inherited by the other servers. So if you look back at, is that this one? No. Sorry, I'm getting ahead of myself. So getting these resources in the database is all nice and fancy and stuff, but you still need to get them out of there because you can't really use the information from the database for your Icinga instance. So what we do here is we fetch the exported resources based on the nodes variable. So in this case, this piece of code runs on the monitoring machines themselves, and the host name would be the host name of that monitoring machine itself. So it'll only get the services and the hosts that are defined or specified for that monitoring machine. Put some requires in there because you need to have the directories, otherwise you can't place the files in the directories. Okay, so creating the configuration, that's all great and stuff, but you want to make sure that your configuration is actually valid. So one of the things that we added to the Icinga class is we created a very basic configuration file for Icinga, which specified just the paths of where the configuration files are, and have that run with the -v option to verify the configuration. Now, if that thing fails, then the entire Puppet run stops. So if it fails, it'll leave the configuration files in the pre-generated directory, and it won't do anything with them, and it'll just leave your monitoring host up and running. If it succeeds, it moves on to the next part, which is moving the configuration files. So what it does is it removes all of the current configuration files in the Puppet directory, and it moves all of the configuration files in the Puppet generated directory into the regular Puppet directory. And after that, it restarts Icinga. Now this is a very, very nice solution as long as you don't have an environment that's too big. In our case, the Puppet runs, they started taking about 10 to 30 minutes. So if you want to run Puppet on 12 machines, I mean, sure, we do them in parallel fashion, but it still takes you about 30 to 45 minutes for all of them to finish. Now, I don't want to wait 45 minutes for my monitoring configuration to be put on that machine. And it's especially annoying if you want to make quick changes. So if you have one configuration problem, you want to know that before, or if you specified the wrong configuration, check. You don't want to wait for 45 minutes for that to finish, figure it out, make the change, check it in, run it again, and wait for another 45 minutes. And it's even more annoying if the Puppet run fails. So it does the verification check, but it does that right at the end of the Puppet run. So if you just spend 30 minutes waiting for your Puppet run to finish, and right before the end, it's like, oh, sorry, I have a problem here. I'm not going to finish my Puppet run. Then you're like, yeah, I just waited 30 minutes for that. Couldn't you have told me that before you started running? But no, that's just the way it works. So. And we figured that most of the time that was spent on this was actually retrieving these exported resources, processing them, and writing them to disk. So yeah, we ran with this for a while, but at some point I got so annoyed, I figured, what the hell, I'm gonna do this myself. It can't be that difficult, right? So I sat down one afternoon and I created get Icinga Puppet resources.py. Basically what this thing does is it has two defined queries. It gets all the resource IDs from the database, and for each of those resource IDs it gets the parameter and the value, and it writes it in the proper format to the file as it is defined in the target. And this thing finishes within 15 seconds. So I'm not entirely sure what's taking Puppet so long, but if it can do it in 15 seconds, then something must be a little bit off there. And this is how it looks in Puppet to actually get these exported resources. So it just, you specify the exec, you give it a name, you specify the command as it needs to be run, and again, the requires are in there. And you need to adjust the requirements before actually checking the configuration file, because it doesn't make sense to check if you don't have the configuration. Now, there are some other cool things that we can do with Puppet. Like I said, Puppet knows everything, but you can also expand Puppet with modules, libraries, stuff like that. So we have a bunch of daemon servers running, and they have a bunch of daemons running on them. Some of these daemons, they run on all of the machines. Other daemons run on only 1 or 2 machines. Others run on half of the machine, so it's very difficult to figure out which daemon is running on which server, because basically the only one that has control over that right now is development, and I'm not going to ask developers every single time, hey, have you moved your daemons or have you added any new daemons? So I figured, do it myself. And now, I don't know how many of you know Ruby or Puppet, but what this thing basically does is it creates a so-called factor called Hyves daemons. It just loops through the entire configuration file and fetches all of the unique daemons or the daemon names as they're specified in that configuration file, and returns a unique array to Puppet. And this is how we define all of our daemons. So we have a daemons class, which is included in for all of the daemon servers. And we have a custom definition called add daemon check, which doesn't involve a whole lot more than just specifying the exported Nagios resource. It uses the name variable over there. That name variable is being passed on to that resource when you specify this here. So what happens, this is the variable as it was specified in the factor. So that's basically the array. It loops through the entire array, and for each item in there, it puts the name of the daemon in the name variable, and it just creates the daemon check for you. Okay, so like I said, I'm not a big fan of getting multiple text messages for the same problem. Same thing goes for daemons. If someone screws up and the daemon code breaks, again, I don't want to have 12 text messages saying, oh, this daemon just died. Oh, this daemon just died. I just want to get the one text message. So what I do here is I use the Icinga API to get me a list of all of the unique daemons that are currently running in our monitoring setup. So this piece of code runs on our NOC server. The NOC configuration is generated after we generate the regular monitoring configuration. So they've already loaded up their latest configuration, inserted the information into the database. So everything that's currently in the API when this piece of code runs is up to date. So I always get an up-to-date list of all of the daemons that are in the configuration. Yeah, it's not very interesting to explain all of this. Basically, it just does the HTTP GET for the proper constructed URL, where the service name equals something with daemon in it, and it returns the service name column, and it uses that result to put that in the daemons array, which is then generated into a unique, an array of unique daemons. And this is how we use that. So we create a local variable called daemons. We say run the function get daemons, which is this thing. We say specify a template file for all of these daemons, and use that variable array in the template itself. So it'll create this piece of code for each of the daemons that are specified in that array. And that'll give you a complete list of all of the daemons that are currently running. Okay, so deployment. I don't want to loop over all of our monitoring machines every time I want to deploy something new. So what we did was we built a relatively simple Python wrapper script, which forks the Puppet runs for all of the monitoring machines. It then waits for them all to finish, and it collects the status information of that Puppet run. So it gives you a big red fat warning saying, oh, your Puppet run for machine this or machine that just failed. If it's all okay, it's all green, and it just continue running the NOC monitoring host. One of the other things that we have in this deploy script is notifications. So what it does is it sends a message to our IRC channel, and it says, oh, Jeffrey is right now Jeffrey is deploying 12 monitoring servers, and that's starting in 20 seconds. We put the delay in there so people can shout at me at IRC saying, oh, hey, wait up, I got something that I need to check in as well, so we don't have to keep on redeploying everything, so we keep that to a minimum. And again, once all of the regular ones start, it'll deploy it for the NOC machine as well. Okay, so, but what if a machine doesn't run Puppet? If a machine doesn't run Puppet, it's not going to generate any monitoring configuration for you. Now, first of all, if someone sets up a machine, doesn't properly configure Puppet, and doesn't run Puppet on that machine, and then sets it to operational, I'm going to smack him over the head with a rubber chicken, because it's just a policy in our company. Configure everything in Puppet and use Puppet. Make sure everything is Puppet controlled, because if that machine dies and he happens to be on holiday, we're the ones who are going to have to figure out what exactly was running on that machine and how do we retrieve it. On top of that, what we have is we have a check within our monitoring to check its own configuration. So it gets a list of all the operational machines that are currently in our server management database and should be up and running. It also retrieves a list of all of the hosts as they are configured in Icinga by using the Icinga API. And it'll give me a notification saying, hey, I'm missing monitoring for server X or server Y. And we also check whether or not the notifications are on. Because having your monitoring in place for a server, that's all great and stuff, but if you still have your notifications turned off for that thing and it goes down during the night, then no one will know, so they need to be on as well. So what about failover? We don't really have a automated failover for our monitoring, but the way to do that is that we need to run Puppet on all of our machines. Now, doing that takes quite a lot of time and isn't really necessary to actually run Puppet on all of our machines. So what we did to speed up these Puppet runs is use the --no op option. So it'll generate all of the resources, exported resources, stores it in the database, but it doesn't actually change any file, install any programming. It just does that part. One of the other things that we can do with Puppet, which they actually fixed recently in 2.68 or 2.7, I don't remember exactly, is you can use tagging. So what you can do is, I don't think it did that here though. Well, what you can do here, for instance, is you can put a tag on your Icinga class and say that the tag name is Icinga, and you can then run Puppet with just that piece of text. So that allows you to just run Puppet for the monitoring module, for instance, but it'll probably still all collect all of the information that you need. Yeah, so and once that's finished, just redeploy Icinga and it'll rebuild the entire configuration from scratch again. Now, because the notifications are turned off by default for machines that are currently failed, you're not going to get notifications from a machine that previously didn't know that monitoring host. Because one of the problems that you have with a distributed setup and failover like that is if you acknowledge some problems or you turn off notifications for a service or a host, and you do that on that monitoring machine, the other monitoring machine doesn't keep that status information for you. So it'll start rechecking it and it'll start resending notifications to you, which means you're going to get a whole bunch of notifications for problems that you're already aware of. So that's another reason why we say, but have Puppet turn off the notifications by default as the default in the configuration, so we don't have that problem anymore. Okay, so that's it for the Puppet stuff. Our system engineering team, we feel very safe and comfortable in the terminal, and especially during large problems, you don't want to have to switch over to a web browser, click through the web browser, get the information of any problems that are currently there. So what I did was I created a command line tool called ICL. I actually called it Icinga Action at first, because it made sense. But then I started getting some complaints from my coworkers saying, no, it's too much typing, it needs to be shorter, it needs to be shorter. So like, okay, ICL, is that short enough? And luckily it was, because otherwise you just end up with I or something, and it doesn't make much sense. So what is ICL exactly? ICL is a Python-based command line script. It uses some libraries that I created myself. These libraries, they can give you access to the API for Icinga Web. I also created some libraries for MK Livestatus, because there's a few things that unfortunately you can't do with the Icinga API, such as turning off text messaging notifications for a specific person. Typically how it works with us is when someone is on call, we automatically turn on their text notifications. And during work or when they're not on call, we also automatically turn them off. Unfortunately, that is, as far as I know anyway, not something you can do with the API. Someone says it can, then please prove me wrong. There's also a general library that allows you to translate exit code, so the only thing you need to do at the end of your checking script is say Icinga.exit_OK or warning or critical, so you don't have to keep thinking about, oh, which exit code was critical again. And it also allows you to translate the status, so if you get a status from the API, you can translate that number into a readable status. Now that's especially handy because the script allows you to retrieve host and service status information quite rapidly. I'll show you some more of that during the demo. It also allows you to quickly control your monitoring and alerting. So if you've got a big problem, like I said, we've had phones crashing with too many text messages. It can still happen, because unfortunately we don't catch all of it, but you can quickly turn off notifications such as text messaging and things like that. It also allows you to just acknowledge problems in batch, turn off notifications for new servers in batch, and it also gives you the ability to quickly see any open problems. Now in our case, this thing the open problems view doesn't show any acknowledged problems, but it also doesn't show any problems that have the notifications turned off, because we generally tend to just turn stuff off and not acknowledge everything every single time. So yeah, that's another thing that could be interesting is whenever we use the MK Livestatus libraries, it'll first use the API to retrieve which host is currently monitoring the host for which you want to get some information or perform certain actions. So you don't have to go over all of the monitoring hosts that are currently running, sending that external command saying do this or do that now. It'll just use the API, it retrieves one of the monitoring hosts that is currently monitoring that machine, so you just have to connect to the one monitoring host. Now these libraries, they integrate relatively well with all of our other tools. One of the biggest things is that we have scripting to quickly change the status of our servers, so we can fail a bunch of servers right at a time. If you fail a machine, it'll disable the notifications for you. Same thing, if you set it to operational, it'll turn the notifications on. What it does as well is it retrieves the status information from the Icinga API to make sure that all of the checks are okay, because you don't want to put a database server on operational when the database isn't running, because, well, it's going to cause problems. So the script will fail and refuse to set the machine to operational if not all of the services are okay. If you set it to deprecated, which basically means that if a machine needs to go back to the vendor or we're selling it or whatever, it'll turn off the notifications for that run, and it'll also remove the Puppet resource from the Puppet database. so that doesn't show up again when you do the redeploying of your monitoring. It also integrates very well with some of our failover scripting. If you fail over a database cluster because one or multiple machines are broken, it'll fetch a machine from our reserve pool. So it puts in a new machine, runs Puppet, copies over the database, and at the end of it, it'll deploy the monitoring, so you make sure that all of the machines that are right now in that cluster are actually in your monitoring right now. And again, it allows you to check the status of hosts and services before continuing your scripting. Okay, so I put together a little demo. I hope you can read this, because it's... No, it's too dark, isn't it? That kind of sucks. I think I have that over here somewhere. That's not any better, is it? Damn it. That's a video. I pre-recorded the whole thing because my coworkers are currently working and I'm afraid that they're going to interfere with the demo. So, can't really increase this thing. Okay, well, that sucks. Okay, well, I can try to give a live demo then. Where the hell did my mouse go? Come on. Why won't you connect? Specified host is unknown. What? Yeah. Oh, the Wi-Fi is up. Yeah, this is a public domain name, so I don't need a specific DNS server to resolve it. I think I just don't have an internet connection. Probably, yeah. Ah, yeah, see, it's not connected. Oh. That's going to take a long time if you don't have an internet connection. Okay, I'll probably need to log in again. Oh, okay, so it works. Great. Ah, there we go. That's more like it. Yes, okay. Hang on, let me just remove the monitoring host from Puppet right now. Okay, so if I use ICL and I specify web1, can everyone read this, by the way? Is that clear enough? Or I can't really decrease the size because it makes it very hard to read the whole thing. Okay, so it's in here now. Damn it, I need to deploy monitoring now. Oh, it's got the 20-second timer. So this is why I don't like doing live demos. It's just... Okay, hang on. I'll just show you how the ICL thing works then. So we've system web1, which is currently... Sorry? Ah, right, yeah. If my mouse can find the corner. Is that better? Okay, so ICL minus system web 1, and it'll give you an overview of all the current services that are running right now. It'll show you the status of the host. It'll give you information on whether or not the notifications are enabled, whether the checks are actually active. If the service has failed, it'll tell you whether or not the problem is acknowledged. And I added the attempt account, which could be interesting, I suppose, and the output of the current checks. Now, if I were to go to web 1, I hope my colleagues are going to get angry by doing this, and I turn off Nginx on this thing, and I say ICL system 1 service HTTP. Okay, so it's currently operational, and I say action, check it, and it'll force a check of the HTTP command, and it should come back critical. Yeah, so now it's critical, and it says connection refused, blah, blah, blah. SVADM, which is our tool to turn stuff off. So I say fail web 1 right now, and it'll set all of the notifications for web 1 to disable. So right now, if you pull up the information for web 1, you'll see that all of the notifications are turned off right now. Now, if I try to put this thing back operational, it'll schedule a check of all of the checks that are currently on the machine, because it could be that the monitoring is lagging behind even though HTTP is already running. But right now it's not, so it'll give you a big error saying, right now the HTTP service is not okay, so I refuse to put this thing online. Now if you look at ICL open problems, you should not see web 1 in here right now, by the way. Yeah, see, I was afraid of this. There's a bunch of crap in here. Sorry, staging environment, so stuff tends to break. Okay, so I go back to web 1, and I start Nginx, and I say web 1. Service HTTP. Action, check it. And this thing should come back in a few seconds. Yeah, so it's okay again. So if I attempt to put it on operational now, it'll succeed, and it'll just put the machine back in the load balancer, and everything's fine again. And again, it'll also enable the notifications for web 1 right now. You can do similar things with this, like acknowledging problems. So if you take a look at the open problems view, you'll see that right now the YouTube item iterator daemon is failed for daemon server 4. So what I can do is I can say daemon server 4 service this action acknowledge. It'll acknowledge the problem, and if you pull up the open problems view, it's gone. Oh, and there's a new one in place. As I said, staging environment. Things break. Yeah, I mean, I can show you how the deploy script runs, but it's not very interesting. Right now, it's mostly just waiting for the puppet run to finish. But again, it says wait for 20 seconds. No, I'm not going to show this because everyone will be waiting around for that to finish. Okay, so I guess that's it then. Does anyone have any questions or comments or anything else? Yeah?
Yes. The ICS, was called ICS, the command line tool, but
Yeah.
ICL is based on the API, is it right?
Partially, yeah.
Yes. And are you thinking about to give this project back to the Icinga?
I just remembered I have one more slide. Plans for the future. So I want to upgrade to
Wonderful.
1.6
Yes.
at some point. As far as I know, that's coming out today, right? Yeah? Okay, so who knows, maybe I'll migrate the whole thing tomorrow. You know, living on the edge. I want to clean up the ICL code because right now there's a bunch of crap still in there that doesn't necessarily have to be there. And I want to make sure that it's compatible with 1.6 because I don't know how much has actually changed in the API compared to 1.4. So yeah, I might need to make some changes there to actually get it to work. And I'm planning on putting it up on GitHub once I've stripped out some of the stuff that doesn't need to be in there. One of the other things I want to do is I want to be able to expose the API to our developers so we can have more valuable information about our daemons. I mean, if a daemon crashes and right now it says, yeah, it's crashed, but I don't know what's wrong, I still need to look at the server to see what's actually wrong. So it would be very nice if they could build something within the daemon that just sends something to the API saying this is the current status of this machine and this is the reason why it failed. And I'm thinking about doing some trend analysis based on our ganglion graphite setup. But to answer your question, yes, I am planning on putting everything up on GitHub at some point. There's a link in here as well to Puppet if anyone is interested in that. There's the GitHub link as well on the slide, and if you want to contact me, you can use any of these methods. Are there any other questions?
Yeah. You talked about the Pyro wrapper for deployment within Puppet, and I want to ask if you tested the M Collective thing from Puppet Labs.
No.
Yeah.
I have not.
So because it looks quite similar.
Yeah, it does. Right now, the scripting, it's quite bulky and it integrates with a whole bunch of other stuff that we do. So the scripting, I modified it basically to suit our needs. And to be honest, I haven't really looked into the whole M Collective thing that deep, but I've seen a presentation about it and it pretty much does the same thing. But I think that actually does active checking in a parallel fashion, right?
Maybe. I don't get into the M Collective thing that deep.
Any other questions? No one? Okay then. Thank you very much.